So I wanted to make a video showing you how to do problem number 27 in the 11.1 exercise set. And the reason why I wanted to make a video is that going over in class will take a little bit of time. And I just want you to have this video to refer back to and to look at. This is a wonderful homework question, but not a great exam question. But I really feel it still has some merit. And so as you look at this problem, I've copied the problem here so that you can see it. And then I've made that circle a little bit bigger so that we do the first step, and that is really understand what they want us to answer. And so they're describing these curling rings, and curling is a game, and these are legitimate types of measurements in there. And so as we read through there, it says it has 4 concentric circles on the ice with radii of 6 inches, 2 feet, 4 feet, and 6 feet. And so down below in this larger circle, I kind of drew a picture of that. So the little black line in there shows a radius coming out from the center just to that first, to create that first white circle in the middle. And they're saying that that has radius 6 inches. Well, that inches is different than everybody else, so I converted it to feet so that it would match everybody. So we're going to need to do that. So we have a half a foot. If you remember, there's 12 inches in a foot, and so we have half a foot as we only have 6 inches. Then the next one they mention is the blue circle that's created, and that has a radius of 2 feet. And it's both the blue and the white circle together that's in the middle, but that second circle that's out has a radius of 2 feet, and I have that in green. Then the next circle that's formed has a radius of 4 feet, and so I have that drawn in red. And then the outside circle is 6 feet in radius. So we can look at this and think, well, this isn't really a normal problem. And you're right, because it's going to take some background effort on your part, but essentially it's the same. As they ask for the probability of it being red, like they do in question A, well, then we need to know the area of the red, and we need to figure out how much of that area of the red circle, and actually maybe I should reword that a little bit and say, instead of area of red, maybe call that the red area, and that's over the total area. That will give us the probability that we hit the red section of that target. So let's work on that total area, because no matter what question we ask, we are going to have to need to find the total area that's in there. So as I do that, let me erase this for just a minute so that we can stay close to this circle. We recognize that the total area is just this outside one that has a radius of 6 feet. Make that look a little bit better, 6 feet in there. Well, we know how to find the area of a circle. The area of a circle is pi r squared. And so the area of this one happens to be pi times 6 squared, or 36 pi. And we're going to leave it in terms of pi so that it's exact, because what they're expressing in the back of the book are fractions. And so no matter what probability they ask us, remember they're asking us 3, probability of red, probability that it's white, probability that it's blue, we're going to have 36 pi on the bottom. So let's go figure out the probability that it's red. So question 27A is, find the probability that you hit the red part of the curling circles. And so, as we mentioned before, this is simply the red area, and then that's over total area, but we know that total area is 36 pi. Okay, so all we have to do is figure out the red area. Maybe easier said than done. So the red area, if we focus just on that, is this area out here. And so how do we find that? Let me go change colors again. Well, that's the big area that's formed by the 6 radius. And not put that right there in case that's confusing. This is 6 feet. And then we're subtracting out all of this stuff because the only part that's red is this outside circle. So we're going to subtract out all this inside piece right here, right? We need to take all of that out regardless of color because it's not red. And so let me get rid of all of those marks so when we come back, it's nice. So easy. We just need to say, okay, I need to take my 6-foot circle. So it's the area of the 6-foot circle, which is 6 pi r squared, minus the area that's in the middle, which is formed by 4-foot squares, or 4-foot radius. So this is 36 pi minus 16 pi. So the area in red is 20 pi. Awesome. I'm done then. I can come back up here and place those numbers in. So the probability that it's red is equal to the red area. Again, that's the 20 pi all over the total area, which we already knew was 36 pi. So again, let's make sure this makes sense to you. What's happening with this 20 pi is it's just this outside area right here. We got that by taking the area of the full circle. Actually, let me do that in a color specific way. We got that by taking the area of the full circle and taking out the area of the inner pieces that weren't red. And so let me put that in a different color. It's not even involved here. So we took out all this green stuff because what that left us with was this outside red circle here. Well, 20 pi over 3 pi is not going to be in the back of the book. Would I take it on an exam? Sure, I guess, but look how much we can reduce here. The pi's go away. That's why we want you to leave it in terms of pi. 20 over 36, both have 4 that goes into them. So the answer in the back of the book is 5/9. That is the probability of hitting that target or having our curling circle end up in the red portion that's there. The next one that they ask about is white. So part B says, hey, what's the probability that we end up in the white area? Well, we know that's always going to be over 36 pi. The question is, what's the white area? And as we look at this circle, we realize that there's 2 white areas. There's the tire piece right here, and then there's the inner white circle. So let's go work on the tire piece. So if you remember that circle, it had an outside red, then the next one was white. So this guy right here was white. Let's get that portion right there. And then just to remind you, this inside piece right here is white. That's what we're after. Okay, so we're going to first concentrate on this area right here that I'll shade in green. We want this white ring, which I'm now making green. Okay, no problem. We'll do it the exact same way. Well, we know the area from the center out to this outside ring right here for the white is 4. So that's 4 squared pi, or let me put it in the right form. It's pi r squared, right? So I'll write it like that. So it's pi times 4 squared. That would give us that full circle there. But then we take out the inner one, and that inner one, I'll put in blue. That inner one right to there is 2. So that's minus pi times 2 squared. Okay, so that's 16 pi squared minus 4 pi squared. Okay, that's 12 pi squares. Great. Okay, now what is that? The 12 pi squared is just that green white ring, right? It's the white tire type of object right here in the middle. It's this one right here. This is the one that is the 12 pi squared. Obviously less than the red in there. So let me back this up a little bit to get those marks out of there. If we need to refer to that again, it'd be a little bit less confusing. Okay. So 12 pi squared is part of our answer. So that question mark up there starts to get replaced with, let me find my eraser here, with 12 pi. Oops, and I apologize. The pi shouldn't be squared. I keep saying pi squared, but there's no reason to square those pi's. So it's 16 pi squared minus 4 pi squared for 12 pi. Hopefully you'll be forgiving there because I don't want to go remake the whole video for a small mistake. But then we have this little piece that's in the middle, right? This guy right here that's also white. So I'm going to make, that's that little piece. I'm going to make it bigger just so we can look at it. And if you remember, it is just a ½ foot in diameter. Well, ½ foot in radius. So no problem. We know the area. The area is 1/2. The area is pi r squared, right? So let me say that a little bit better, keeping that pi first. The area of a circle is pi times its radius squared. So the area here is 1/4 pi. So what is that? That's this little dot in the middle all filled in, right? So we know that that area is 1/4 pi. So we know the area of the white is 12 pi plus 1/4 pi. Well, we got to put those together. So 12 pi is 48 pi over 4 plus 1/4 pi is 49 pi over 4. So now we got 49 pi over 4 all over 36 pi. Well, those pi's are going to cancel again. But how do we deal with this 49 pi over 4 all over 36? And the answer to that is very carefully. So I'm going to erase this background work knowing that you can go back in the middle just to stay really close to this. And I'm just going to backtrack a little bit, make sure that we're all on the same page. So what we had is a numerator that needed to be figured out. That numerator was 12 pi plus 1/4 pi. So the first thing we're doing is simplifying the numerator. Or the top part of the fraction. So that's taking 12 pi and adding 1/4 pi. Well, in order to add these guys together, these numbers, I have to have it as a fraction. So 12 can be written as 48 divided by 4. 1/4 already had the 4 on the bottom. So that's where I'm getting the 49 pi over 4. So now we have the 49 pi over 4. And I'm going to write that a little bit differently so that you can see this cancellation work out better. 49 over 4 pi divided by 36 pi. The pi's cancel out. That's where I was. And now you have this 49 over 4 all over 36. Now the easiest way to handle this is to remember that 49 over 4 all over 36 is just a fraction, and fractions are just division. So this is 100% the same as 49 over 4 divided by 36. If you remember our fraction division, we would change all division into multiplication by flipping this second fraction, and 36 is 36 over 1. We would now look at these numbers and say, well, what can we cancel? And in this case, nothing. 49 is only made up of 7s. 36 and 4 have no 7s. And so there's nothing that can cancel. So my top number is 49. And my bottom number is whatever 36 times 4 is, which is 144. So 49 over 144 is now the probability that it's white. So the probability that it's white is the hardest one to figure out, I think. And that is 49 over 144. So you can see why I did a video solution of this, because you need to go back and see it always. So hopefully that makes sense when you review it. Again, wonderful homework question, but not a great exam question. So the last one is actually nicer than the middle one. The red one was the nicest because it was one contained area. Blue is also one contained area, so that's going to be somewhat nice, but we're still going to have to deal with fractions. The white one was the hardest because it was two separate areas. Again, that 12 pi area and the 1/4 pi area. And it's really that fraction that's messing us up. I wondered why they picked a fraction, and then I realized, well, they're using a real example in all of that. So if you remember our circles, the outside rim was was red. Then we had a white, right? So this was red, white. Then we had blue, and then a white one again. So let's look at that blue one because we care about the blue. If you remember, this was 2 feet, and this was just half a foot. I'll keep everything in terms of feet. It was 6 inches, but this is 2 feet and a half a foot. So now we're going to do the same thing. If we want to find the probability that it's blue, we need to find the blue area. That blue area is the outside circle, which is pi r, in this case 2 squared, minus the inside area, pi times 1/2. Okay, well, what's that? That's 4 pi minus 1/4 pi. Okay, we can do that. That's 4 pi. Let me change that. I was just going to write the same thing again. Hopefully this is okay with you. That's 16 pi's over 4, right? 16 divided by 4 is 4, minus 1/4 pi. So that's 15 pi's. 15 over 4 pi, right? 16 minus 1 is 15. So the blue area is 15 over 4 pi. Great. So the probability that we land in blue is equal to that blue area, 15 over 4 pi, divided by 36 pi. And if we remember from what we just did, the pi's will cancel out. So using red, these guys are gone. And then I'm going to look at this just like we did before and say, well, this is not hard. This is just a fancy way of saying 15 over 4 divided by 36. And then we remember, oh, that's 15 over 4 times 1 over 36, right? Because this was 36 over 1. So we change it to multiplication and flip that second fraction. Here we have some reduction that's possible. Both 15 and 36 have a 3 that goes into it. So if I go and take out that 3, I get a 5 here and a 12 here. And so in the end, what I end up with is a 5 over 48 probability that it lands in the blue area. So to summarize, I guess I don't need to summarize because you can look back in the video, but we got a probability of blue of 5 over 48, probability of white of 49 over 144, and a probability of red of 5/9. Each time finding the area of the desired color over the total area, which we saw early on was 36 pi. Hopefully this helps. I won't heavily grade this problem, so just understand it as best you can. It's just good from an intrinsic value. So thank you for watching this.